All right, in this video, what I want to do is show you how to write the equation of a parabola in standard form, either using the intercept method or 3 points. Now, as long as you have 2 points, you could use either the intercept method or you could use this 3-point method. So we're going to kind of look at both methods and kind of determine which one is going to be the preferred method for you. So I think it's important, if we're going to understand writing an equation or writing a parabola in standard form, we need to understand what is standard form. So standard form of a parabola is going to be y equals ax squared plus bx plus c. All right? Or at least for our quadratic, that is what we are going to be looking for. Now, in the first example, we can see that we have two x-intercepts, -4, 0, and 2, 0. And then we also have the y-intercept. So it's very nice when we have these intercepts because we have 0. And that's going to be to our advantage when we're trying to write the equation. Now, there's a couple things to think about when we're looking into writing the equation. For instance, when we're given the x-intercepts. Because we could write the x-intercepts as coordinate points. We could also write them as solutions. For instance, x equals -4 and x equals 2. And if we remember how we find our solutions algebraically, we came from these by using from like the zero product property. Either quadratic formula could be the case, or typically by factoring. Now, if we were to look at this as the solutions, these could come from our zeros. For instance, I could rewrite this as 0 equals x. Oh, let's actually write this like this. X plus 4 equals 0. X minus 2 equals 0. And you might be thinking, why did you write those? Where did those come from? Well, again, if you were to think about these coming from the zero product property, I could write this as x plus 4 times x minus 2. Now, again, think about this. If I had a quadratic equation that was already in factored form, right? And I said, I want you to solve this quadratic. Well, one of the ways that we solve a quadratic or find the x-intercepts of that quadratic is we set y equal to 0. So what we do is we take this equation, which would be like y, and we could say x plus 4 times x minus 2. OK? Now, what's going to happen here is you would go ahead and multiply this out, and that would give your equation. So what I'm doing is I'm kind of working our way backwards. Because if I look to find the x-intercepts, you'd set the equation equal to 0. By the zero product property, you could set each factor equal to 0, and then you'd solve. And those are going to be the x-intercepts. So if I give you the x-intercepts, you can write them as factors, write them as a product, and then write them into an equation. So all we have to do now to find our equation of our parabola is now just to multiply these. And we can multiply these out using just your standard FOIL. So outer, inner, inner last. So therefore, when multiplying this out, I get a x squared plus, let's see, 4x minus 2x minus 8. So therefore, y equals a x squared, let's see, plus 2x minus 8. All right? But hopefully, if you look at that answer, you realize we made a mistake. Something's wrong. Because if I look at this y equals x squared plus 2x minus 8, you realize that parabola should be opening up, right? And our parabola opens down. We need to have a negative a. So there's something that's very important about this, or something that's very important in the understanding about your quadratic and your parabolas. Having the intercepts is not enough to know what the equation of the graph looks like, right? Because this graph could look like this, right? It could look like that. It could look like that. Like, giving us just the x-intercepts does not give us enough information. So the nice thing about that is we could have a value a that is going to stretch or compress the graph, as well as flip it about the x-axis that would not change those intercepts. And so we can use that a, if you recall from your characteristics of if you use the characteristics of your parabola. So now what I can do, if I want to solve for this a, well, I need to figure out another point. Now, what other point could I possibly use that would help us determine what is going to be my value of a? And you can see right here this nice, lovely y-intercept. So all we're simply going to do now is I'm going to solve for this a. I'm going to plug in the point 0, 8 to solve for a. So I'll say 8 equals a. And then that needs to be multiplied. Make sure your a is multiplied by everything. I know it's very common to think just, oh, a is just by the x squared. But we got to think a as this multiple. It's a scalar. We're actually going to be multiplying by everything. And then our final value of a will just be out in front. But right now, the scalar is going to be in front of our whole quadratic. Because technically, this is like the factored out form of our scalar a. So I have a, and then this would be times. Let's see, if we plug in 0 in for x, that'd be a 0 squared plus 2 times 0 minus 8. Okay? So we have 8 equals a. When you multiply all this all together, you get negative 8. Divide by negative 8. Divide by negative 8. Let's keep the a green. You can see here now a is going to equal negative 1. Okay? So now I'm going to go back to my equation, and I'm going to say y equals this negative 1 times x squared plus 2x minus 8. And now all I need to do is distribute this to get my final equation of my answer, negative x squared minus 2x plus 8. And it's very important for you to understand that the negative, again, is not going to be changing the intercepts, right? I could have the same graph. If when I multiply by negative, all that does is flip the graph about the x-axis. It doesn't actually change the intercepts. So when you have the intercepts, the x-intercepts, what you're going to want to do, again, is write them as factors to multiply them out. However, you're still going to need a third point. Hopefully you have that third point is the y-intercept, because when you have 0, it just makes your math so much easier. You can use 0 to go ahead and find the value of a, and then make sure you distribute that a across to all the values. But this is only going to work when we have both x-intercepts. So you can see in the second method, or in the second problem, what we have here is I don't have all of my x-intercepts here. I only have one x-intercept. And I do have the one y-intercept. That's good. But then I also have this other random point. So in this example, we can't use the same method. We can't set up our x-intercepts and write them as factors to be able to multiply. In this case, what we're going to need to do is set up a systems of equations, because we recognize that all of these points can represent x's and y's, and I can substitute them in to the equation for a standard form of a parabola, y equals ax squared plus bx plus c. And if I have three unknowns, right, a, b, and c, well, then all I need is three equations. And fortunately, I have 3 points that I can use to plug into those 3 equations. So let me show you what I mean. So let's take the first point. All right, let's take this first point, and let's plug this into, let's do this, here's x, y. Let's plug this into our first equation. So I could have, let's do y. Actually, I'll use green here. OK, so I could have y equals, and then I could have a times ax, right? Oops, I'm sorry, y equals 0, right? So we're going to replace y with 0, equals a times x, which is a negative 2, squared, plus, let's see here, we're going to have a b times negative 2, and then plus c. OK, so all I'm doing is I'm replacing x with negative 2, and I'm replacing y with 0. Now again, we can do this again. We can do this with this equation. So by doing this, I'll plug in a 0 in for, did I redo this the other way? No, I did do that. That's 0 comma negative 2. Dang it. Wrote that down. That's 0 positive 2. OK, so I did that one all wrong. So let's do this one. That would be that equation. Don't mind me, my mistakes. OK, so that's going to be this equation right there. Fortunately, I was able to escape that. Now let's do it for this equation. So I'm going to plug 0 in for x and 2 in for y. So I have a 2 in for the y, and that's going to equal a times 0 squared plus a b times 0 plus c. And then let's go and do our third equation. So that's going to be for that one. And then our third equation, that one's going to be an 8 equals a times 3 squared. Yes, 3 squared plus a b times 3 plus c. Now, the cool thing that's going on here is that we have, if you look at this equation gets, if we simplify this, I can break this down into 2 is equal to c, because 0 times a is 0 and b times 0. So the reason why that's important is because now if I know the value of c, let's go ahead and simplify these 2 equations here. I can also replace now 2 with c. So if I take this equation, I can now rewrite this as a 0 equals a 4a plus 2b plus 2. Right? All I'm simply doing now is plugging in my 2 in for c. And then I can take the second equation, 8 equals a 9a plus 3b plus, again, another 2. Because C represents 2. So you can see here, now I have a system of equations. And now all I simply need to do is go ahead and set up my system of equations where my variables are all going to be aligned, and then identify how I'm going to solve that. So what I'm going to do is I'm going to get these 2's over to the other side, and I'm going to have an equation that's going to look something like this. So let's say it'll be a negative 2 equals 4a plus 2b. And then over here, it's going to be a 6 equals 9a plus 3b. And if you remember from systems of equations, when you want to solve a system of equations, you can either use substitution or elimination. In this case, since I have coefficients of both my variables, I'm going to look to using elimination. And so therefore, I want to find the least common multiple of one of my variables. So in this case, I'll multiply this by a 3. And then here, I'm going to multiply by negative 2. Now, the reason why I'm doing that is because I prefer to add, meaning one coefficient be positive and one coefficient be negative, rather than trying to subtract the equations. So when I multiply this, I'm going to get a negative 6 equals a 12a plus 6b. And over here, I get a negative 12 equals a negative 18a, and then minus 6b. Now, when I add these two equations, I'm getting negative 18 equals a negative 6a, because the 6b and the minus 6b are obviously going to add to 0. Now you can just subtract a negative 6, and you get a is equal to 3. But again, we still need to figure out all of our variables, right? We found a, we already know c, so now let's just go ahead and find b. So to find b, all I'm simply going to do is plug in my a back into one of my original equations. So therefore, I'll just have a, let's see, this was a negative 2. So let's do it over here, actually. So I have a negative 2 equals 4 times 3 plus a 2b. OK? So let's say negative 12 equals negative 2, I'm sorry. I was worried about that. I'm like, I don't remember that answer. So negative 2 equals 12 plus 2b. Subtract, subtract. And that's a negative 14 equals 2b. b is going to equal a negative 7. OK? So now we have our c. Now we have our a. And now we have our b. So now that we have all three values or coefficients, we can write our standard form of our equation, which is going to be y equals a 3x squared minus 7x plus 2. And there you go, ladies and gentlemen. That is how you write the equation.